Welcome to Day 1, Foundations. We created this course to provide a gentle introduction to Prometheus. We know monitoring can be overwhelming, so we try to keep things simple and practical. This course is highly structured to guide you step by step. Today, we will focus on the architecture, installation, and configuration. 1. What is observability? It's not just monitoring. It's asking questions about your system from the outside to understand its internal state. The 3 pillars. Metrics. Aggregatable data. Is it slow? Logs. Discrete events. What happened? Traces. Request journey. Where? Prometheus focuses purely on metrics. Let's dive into the first pillar, metrics. Think of metrics as the answer to the question, is my system slow? These are aggregatable numbers like CPU usage tracked over time. Essentially, metrics are numbers measured at regular intervals, which we call time series. The beauty of metrics is that they are very cheap to store and easy to aggregate using math. However, the downside is they often lack context. You might see a spike, but the metric itself won't tell you why it happened. Common tools for this include Prometheus and Graphite. Next up, we have logs. If metrics tell us something is wrong, logs help us answer the question, what exactly happened? Logs are text records of discrete events. Their biggest strength is the infinite detail and high context they provide for troubleshooting. However, they come with a cost, literally. They are expensive to store and can be quite slow to search at a large scale. Common tools in this space include Loki, Elasticsearch, and Splunk. Finally, the third pillar. Traces answer the question, where did the request go? They track the full life cycle of a single request as it travels across different services. This is incredibly useful for pinpointing exactly where a bottleneck lies in a microservices architecture. The downside is that they can be complex to instrument and often require sampling to manage the data volume. Popular tools for tracing include Jaeger, Tempo, and Zipkin. Now, let's talk about how metrics actually get from your application to the monitoring system. There are 2 main approaches, the push model and the pull model. In a push model, the application is responsible for sending its data to the server. In contrast, with a pull model, the server periodically reaches out to the application to fetch the latest metrics. We'll explore the pros and cons of each in the next few slides. The push model. In this model, the application, or an agent, is responsible for sending data to the server. Examples include Graphite, InfluxDB, and Datadog. It's great for short-lived jobs and flexible targets, but it's easier to accidentally flood the server with data. The pull model. Here, the server actively fetches data from the application. Prometheus and Nagios are classic examples. This provides central control and automatic monitoring, but requires network access to the targets. Where Prometheus fits. Prometheus is primarily a pull-based system. However, for specific cases like short-lived batch jobs, it supports push via the push gateway. Prometheus architecture. Let's look under the hood of the Prometheus server. Core components. The server consists of 3 main parts, the retrieval subsystem, or scraper, which pulls data, the time series database, or TSDB, which stores it on disk, and the HTTP API, which serves the data to users and tools like Grafana. The retrieval subsystem. This is responsible for finding and scraping targets. It connects via HTTP or HTTPS, uses service discovery to find where targets are, and parses their text-based response. Jobs and instances. Retrieval scrapes targets. A single endpoint is called an instance. A collection of instances with the same purpose is called a job. The time series database, or TSDB. It's optimized for high-volume writes. The head holds about 2 hours of active data in memory. The write-ahead log, or WEL, protects this data from crashes. Older data is compacted into immutable blocks on disk. The HTTP API. This is the gateway to your data. It accepts PromQL queries, retrieves data from memory and disk, and returns JSON to Grafana or other clients. Storage details. Data is stored locally by default. We have the in-memory head block, the WEL for safety, and background compaction that merges smaller blocks into larger ones. The data model. Now let's understand what exactly we are storing. What is a time series? It's simply a stream of timestamped values that belong to the same metric and share the same set of labels. For example, API_HTTP_requests_total with a specific method and handler. Metric types overview. We have 4 main types. Counters, which only go up. Gauges, which can go up and down. Histograms, for bucketing observations. And summaries, for client-side quantiles. Metric types. Counter. This represents a cumulative count that only increases, like request counts or errors. It can only reset to 0 on restart. You usually use the rate function with these. Metric types. Gauge. This represents a value that can arbitrarily go up and down, like memory usage or temperature. You can view these raw or average them over time. Metric types. Histogram. These sample observations like request durations. They count them into buckets, allowing you to calculate quantiles like the 99th percentile latency. Metric types. Summary. Similar to histograms, but they calculate quantiles on the client side. They are accurate but harder to aggregate. In modern setups, histograms are usually preferred. The danger of cardinality. Cardinality is the total number of unique time series. It's the count of metric names multiplied by unique label combinations. High cardinality can lead to an explosion of data. Cardinality explosion. Why does it matter? Each series consumes RAM. If you have too many, Prometheus can slow down or crash. Rule of thumb: avoid labels that can have infinite values, like user IDs. Installation methods. Let's look at how to get Prometheus running. Installation overview. You can run it as a binary in a Docker container, via Kubernetes Helm charts, or as a systemd service. The best choice depends on your infrastructure. Option A, binary. You simply download the tarball, extract it, and run the executable. This is great for bare metal or just understanding how it works. Option B, Docker. This is perfect for quick starts and local development. You just run the official Prometheus container. Option C, Kubernetes. If you are in Kubernetes, use Helm. The Prometheus community charts are the standard way to deploy. Option D, systemd. For production Linux servers, you'll want to run it as a background service using systemd. Configuration. Now, let's look at the configuration file, prometheus.yml. Where is the config? It depends on your install. For binary, it's next to the executable. For Docker, it's inside the container. For Kubernetes, it's a config map. File structure. The config has 5 main blocks: global settings, rule files for alerts, scrape configs for targets, alerting settings, and remote write configurations. Global config. Here you define how often to scrape targets and how often to evaluate rules. Default is usually 15 seconds. Scrape configs. This is where you define your jobs and targets. You can list static targets here, like localhost or specific IP addresses. The scrape lifecycle. Every interval, the server connects to the target, gathers the data, parses it, and stores it in the head block. Remember, the timeout must be shorter than the interval. Hot reload. You can change the config without restarting the process. Send a SIOP signal or make a post request to the reload API endpoint. Hands-on lab goal. Spin up your first Prometheus server. Pick your preferred method from the following options. Option A, binary installation, suitable for Linux, Mac, or Windows manually. Step 1. Download. Go to the official website and download the archive for your OS. Step 2. Run it. Extract the files and run the Prometheus executable with the default config. Option B. Docker. Quick and isolated. Step 1. Prepare config. Create a simple Prometheus YML file in your working directory. Step 2. Run container. Mount your config file and run the container, exposing port 9090. Option C. Kubernetes. Ideally for those already running a cluster. Step 1. Install. Add the Helm repo and install the chart. Step 2. Access. Use port forwarding to access the UI on your local machine. Verification. Let's make sure it worked. Check the UI. Open localhost 9090 and check the targets page. Your target should be up. Query metrics. Go to the Graph tab, type up, and execute. You should see a value of 1.